In May 2015, the concrete and construction industry will be changed forever. Make a date with innovation. Make a date for African construction and totally concrete experts.
The Romans certainly knew how to make good concrete, and we have concrete that's 2,000 years old that they made, indicating that they were very good at it. The discovery and manufacture of modern Portland cement was really based on an understanding of what the Romans had done. The critical issue here is that it's this combination of the lime with the aluminum and the silica, or the alumina and the silica, that gives us these stable minerals. Lime on its own is not stable. And the Romans, when they initially did their building, of course, only used lime mortars. When they discovered that by mixing the lime with volcanic ash, they could make a much more durable material, and one also that would set underwater. So that was the beginning of what we call hydraulic cements. Hydraulic cements are cements that can set even underwater, whereas lime materials will only set in air and harden in air. And that allowed the Romans to do amazing things, build harbours, which of course have got water associated with them, build aqueducts likewise that can carry water, build incredible bridges, roads, and even structures like the Pantheon. What we are maybe realizing again is that durability is a critical issue in modern construction. And the Romans inadvertently, I think, hit upon the solution, which was to put in this volcanic ash, which made their concrete very much more durable. And essentially, if we reduce the lime content and put in more of the alumino-silicious content, this helps to create better durability. So that's an issue that we're very much dealing with today. But at the same time, we need to acknowledge that modern cements are very different from what they were even 10 or 20 years ago. There's always something to be learned. And in that sense, we should study these materials and understand how they work. There's also a very important reason for that, because many of these old structures are also deteriorating and need to be rehabilitated or repaired. And in that case, you need to use compatible materials. So whatever is used to help repair them or rehabilitate them should be as similar as possible to the original materials that were used. So there again, there's a real need to study those materials. That's very difficult, because so much of this depends on how we look after our infrastructure. If we maintain and look after it, most buildings, if they're decently built and structures that are well built, will last an almost indefinite period of time. It's a question of whether society is prepared to maintain and repair and look after things as to whether they will stand. We've built some incredibly wonderful structures in the last half a century and even the last couple of decades. Some fantastic bridges. You think of the Millau Viaduct in France, some of the new bridges in China, and even here in South Africa we built some magnificent structures, bridges, new buildings. It would certainly be nice to see these continuing into the future. Very often though, these structures and buildings reach the end of their useful life. Some new scheme comes up, or the building has to change its use, and then the current form is no longer applicable. So that's sometimes why they are taken down, not because they're no longer able to stand up or to be durable, but because the function changes.